In this video, we are going to show you how to perform vulnerability scanning using the Amazon Inspector SBOM generator. So let's talk about what we will cover during this video. We'll start by providing an overview of the tech stack you will be using, and this will help you understand how this solution works at a high level. Next, we'll go over installation and configuration. We'll then show you how to generate software bill of materials for your resources. Finally, we'll show how you can scan your SBOMs for vulnerabilities using the Inspector Scan API. By the end of this video, you'll be equipped with a new approach to perform vulnerability scanning inside or outside of the AWS cloud. So let's talk about how this solution works at a high level. Essentially, we're going to use a tool called Amazon Inspector SBOM Generator. Going forward, I will call it SBOM Gen for short. So the way SBOM Gen works is you first provide it an artifact that you would like to scan. This can be a local system, a container image, an archive, and so on. SBOM Gen will then inventory the artifact you provided, and it will generate a software bill of materials. Now you can also optionally send this SBOM to Amazon Inspector. Inspector will then evaluate the contents of the SBOM and it will send you back a vulnerability scan. So in essence, SBOM Gen gives you the ability to generate software inventories for your artifacts, and it also lets you scan your artifacts for vulnerabilities. In that way, you can better understand the components that make up your artifact, as well as any vulnerabilities that may be present. Now, something I want to highlight for emphasis. SBOM Gen is a single compiled binary. All of its runtime dependencies are linked into the binary itself, and for these reasons, it's very easy to deploy and operate SBOM Gen inside or outside of the AWS cloud. And in fact, we do this in production at Amazon. For example, we use SBOM Gen to power Inspector inside of the AWS cloud, and we also use SBOM Gen to power services outside of the AWS cloud. Specifically, we use SBOM Gen to power our CI/CD plugins, such as Inspector for GitHub Actions, Jenkins, TeamCity, and so on. So with that in mind, you could think of SBOM Gen as a take-it-with-you vulnerability scanner. But be aware, SBOM Gen must have network access to the AWS cloud to perform vulnerability scanning end-to-end. In a moment, we're going to put hands on keyboard and I'm going to show you how to download and execute SBOM Gen. If you are following along with this video, you will need the following prerequisites. First, you will need a Linux host from which you will execute SBOM Gen. We're going to use Amazon Linux 2023 on AMD 64 for this purpose. However, you can also use ARM64 or other Linux distros such as Debian or Red Hat Linux. Now, notice the image on the left. These commands show how we configured our Amazon Linux instance for this demonstration. These tools are not strictly mandatory to use SBOM Gen, but we will use them in this video. You will also need an active AWS account, plus credentials and permissions so you can interact with the Inspector service. Now, if you are a new AWS user, I would encourage you to visit the hyperlink on this slide. This provides step-by-step guidance on how to create your AWS account, as well as configure your credentials and permissions if you're doing so from scratch. If you are a current AWS user, you can create an IAM policy, which you see on this image on the right. This policy grants permissions needed to interact with the Inspector Scan API, and you'll just attach this policy to whichever IAM entity you use to authenticate to Inspector. Okay, so we covered the necessary concepts and prerequisites. We're now going to put hands on keyboard, and we're going to show you how to use SBOM Gen to inventory and scan your resources. So the first thing we need to do is download SBOM Gen. Now, I've already navigated to the Amazon Inspector documentation landing page, and you can see the URL right here. From this page, we'll navigate to the Inspector User Guide. From this page, we'll click the link that says Amazon Inspector SBOM Generator. So now we found the SBOM Gen documentation. There is a lot of pertinent information here, and I would encourage you to peruse this content if you would like to learn more about SBOM Gen. Now, for our purposes, we just want to download the SBOM Gen release package. If you take a look at the section called Installing SBOM Gen, you'll find some hyperlinks. You could find hyperlinks to the latest release right here for Linux AMD 64 and ARM 64 respectively. Or if you need a specific version, you can download previous releases here. Now, if you're following along with this video, we are going to download SBOM Gen 170 for Linux AMD 64. So I'll just copy this hyperlink. And now we're ready to download the SBOM Gen release package. So now I'm going to switch over to my Amazon Linux instance, and we'll go ahead and download and extract the SBOM Gen release package. I'll start by making a staging directory for us to work in. And you can delete this when we're finished if you want to remove any artifacts that you don't want. So I'll use wget, I'll provide it the URL, and we'll download the SBOM Gen release package. Let's take a look at the file size. 7.6 megabytes, pretty small. And we'll take a look at the file type itself, which is a zip compressed archive as we expect. We'll then go ahead and unzip the release package. And let's take a look inside so we can see what we're working with. So I'm running the tree command on the extracted release package directory. Here we'll see a couple subdirectories, Linux, AMD 64, followed by various pertinent files. You'll see the change log, which you can read to see what the latest changes are by version, license for licensing information, helpful README, checksums for integrity verification, and the SBOM Gen binary itself. This one right here is the binary that we're going to be executing. You'll also find additional information on third-party licensing and an SBOM for this release package, which is generated by SBOM Gen itself. So let's see if we can execute this SBOM Gen binary. I'm first going to cd into this directory and related subdirectories. So first you want to make sure that SBOM Gen has execute permissions. In this case it does, but if for some reason yours does not, you could run a chmod with execute permissions. And we'll go ahead and run it just to make sure it is working as we expect it to. Okay, so we've proven that SBOM Gen is correctly downloaded and we're ready to execute it. One more thing I'll point out. I mentioned that SBOM Gen is a standalone binary. If we take a look at its uncompressed size, it's about 20 megabytes, which is usually small enough to deploy to many areas. And if we run the file command on it, we'll see that this is a Linux ELF 64-bit executable. Note that it is statically linked. This means, for the most part, you should be able to deploy SBOM Gen on any supported platforms, and all of the runtime dependencies are part of the binary, so it should just work. Okay, so we've successfully installed SBOM Gen. Let's now explore its capabilities. So let's start by taking a look at SBOM Gen's built-in help menu. I'll pass it the -- help argument, and I'll pipe this to less so that we can page up and down in the terminal. You will find quite a bit of information here, but I'll draw your attention to what you need to get started quickly. So the way SBOM Gen works is you first give it a command. You can see the available commands listed here. For example, if you pass in the localhost command, you're telling SBOM Gen that you would like to scan a local system, such as an EC2 instance. If you pass in container, you're directing SBOM Gen to scan a container image. Likewise for binaries, directories, and archives. We have some other commands as well, for example, list scanners. This will let you view the available scanners so that you can better understand the different package types that SBOM Gen is able to inventory and scan. We also have this command, list examples, where we provide a list of very common SBOM Gen examples that you're likely to want to use. We'll take a look at that momentarily. If you scroll further, you'll see various command line arguments that you can pass to control the behavior of SBOM Gen. We'll make regular use of -o or --out file, which specifies where you want the destination SBOM to go or the vulnerability scan. So let's now take a look at the output from the list examples command. I will once again pipe it to less. So on this page, you'll see a series of commonly used commands when operating SBOM Gen. I'll draw your attention to some of the highlights. We first show you different ways of generating an SBOM for container images. To do this, we specify the container command, and then we use the dash dash image argument to specify the image that we want to inventory. For the most part, we follow Docker pull style conventions for referring to container images. So in this example, you can see we're referring to Alpine latest. If the image is already cached in Docker Engine, we will inventory that image. If, on the other hand, you have not downloaded that image via a Docker pull command, SBOMGen will go ahead and download that for you and then generate the inventory. You can also refer to your images by hash, as you see here. Or if you export your image via a Docker save command, you can scan your image as a standalone tar file. This example shows how to generate an SBOM for a local system, or we call this local host. This is useful if you're trying to scan like a standalone EC2 instance or perhaps a virtual machine. I'll also add that the localhost command directs SBOMGen to inventory globally installed packages. Those are typically packages that you might install using a package manager. However, you can also provide an optional path that will be included as part of the inventory. Example 4, you can see the syntax for scanning a binary. You provide it the binary command, followed by a path to the binary. I'll add that as of this recording, SBOMGen only supports compiled Go or Rust binaries, and it does not support binaries with obfuscation applied. Now, some other commands. You can pass in the directory command if you want to inventory or scan a directory. This is particularly useful if you have a project directory like a downloaded Git repository. We also have the archive command, which supports inventorying compressed archives such as .zip or .tar.gz. Example 6 shows how to write your SBOM to a file. If you omit this argument, it will simply print your SBOM to standard out. But if you provide the -o argument, you can specify where to write your SBOM or your vulnerability scan. Speaking of vulnerability scanning, example 7 shows how to scan your SBOM with Inspector. For the most part, your SBOM generation arguments stay the same. What's different is you add this option --scan SBOM. This tells SBOMGen to not only generate your SBOM, but to also send that SBOM to Inspector for a vulnerability scan. And there are various options to control how you authenticate to Inspector. This is similar to the AWS CLI. We let you specify your profile, your region, optionally an IAM role ARN. And we'll talk about that in greater detail momentarily. More examples are available. I'd encourage you to peruse these because some of them can be useful. Otherwise, we'll go ahead and transition and show you some runtime examples of these commands. So let's generate an SBOM for the local system. I'll invoke inspector SBOMGen. I'll pass it the localhost command, which means inventory the system that we're presently on. In this case, it's the Amazon Linux EC2 instance. And I'll write this to a file called localhost_sbom.json. So we'll press enter. You'll see various console logs explaining what SBOMGen is doing. And let's go ahead and take a look at the SBOM itself. So we can see this is a CycloneDX SBOM in JSON format. As you scroll through the document, you'll see various pertinent information. For example, this block tells you the tool that generated this SBOM. And as you go further, you'll see information describing the operating system, Amazon Linux in this case. And you'll also see information describing packages installed on this system. One thing I'll draw your attention to is this field here called Perl. That is short for a package URL. And this is a structured way of representing package names, versions, and other metadata. When Inspector performs a vulnerability scan, it's primarily looking at these package URLs in order to make vulnerability decisions. Now, SBOMGen has some other CLI arguments that can be useful for SBOM generation and vulnerability scanning. These could include the --EC2 argument, which will add additional EC2-centric metadata to your SBOM. We can also add --collect licenses, and this will give you licensing information for different package ecosystems that support it. And this is actually a new feature as of SBOM Gen 170. So I'll fire this again, and we'll take a look at some of the new data. So we're looking at the SBOM. And if we scroll along, we'll see some new fields for our operating system metadata. This would be the EC2 instance ID. And if we look at some of the packages, we see that they're now decorated with licensing information. These are SPDX license expressions, and these could be helpful if you're trying to determine which licenses your package dependencies are released under. In our next example, I'll show you how to inventory directories and archives. We'll start by downloading a popular project from GitHub. So I'm using the wget command, and we're going to download a project called Cobra, and this is hosted on GitHub, and it will be written to disk as a .tar.gz file. So we downloaded the file. We'll go ahead and decompress it. And I'll go ahead and run a file command so you can confirm that this is in fact a directory. Now we'll invoke inspector SBOMGen with the directory command. We'll specify the path of this directory using --path. That will be Cobra. And I'll write the SBOM to disk as directory sbom.json. So we will fire this, and we'll take a look at the SBOM. Now, since you're already familiar with how the SBOM looks, I'll take this opportunity to draw your attention to some pertinent metadata. If we scroll down, we'll see the various components that were found in this directory. In this example, we can see that we've got a package, part of the Golang ecosystem, called GoMD2Man. Not terribly sure what that library does, but it is considered a dependency of this Cobra CLI project that we just inventoried. Now, this field here is particularly useful. This is called source path. And basically, the purpose of this field is to identify the source file from which this package information was derived. In other words, it's directing us to a file here, cobra 1.0.0/go.mod. This file basically contains the package information that SBOMGen used to produce this SBOM. So if you're ever wondering how SBOMGen yielded a particular package, you can look for the source path property and then look at the file it provides. That file will be the one that contained this package information, and that can be sometimes helpful to understand this if you're trying to triage vulnerabilities or determine if something is a true positive, false positive, and so on. I'll now show that we can scan archives in a similar way. So we'll scan the .tar.gz file that we downloaded. I'll invoke SBOMGen with the archive command. We'll specify the path as this v1.0.0 directory, and I'll write the SBOM to disk as archive sbom.json. So there you have it. That's how you inventory compressed archives. Next, I'm going to show you how to scan container images. We'll first pull an image into our local system. I'll pull in Ubuntu 14.04. And I like to use this for SBOMGen demonstrations because Ubuntu 14.04, given its age, it has a lot of vulnerabilities, which can be helpful when we're demoing vulnerability scanning. So I pulled the image. It was already cached in the system. So let's go ahead and scan it. We'll invoke SBOMGen with the container command, and then we'll specify the image we want to scan using --image. I'll specify Ubuntu 14.04. And we'll write this to disk as container sbom.json. So I'll press enter. Now let's take a look at the resulting SBOM. So this will look similar to the previous SBOMs, but of course there will be artifact-specific differences. Since this is a container image, you'll see substantially more metadata specific to containers. For example, you'll see its image ID, image architecture, the version of Docker that was used to build this image, layer IDs, and so on. Okay, so we demonstrated how to use SBOM Gen to generate SBOMs for various artifacts. Next, I want to show you how to perform vulnerability scanning with Inspector. This is pretty easy. Essentially, we'll invoke SBOM Gen. We'll specify a container, and I'll use Ubuntu 14.04 because we expect that to have many vulnerabilities. And now I'm going to pass in the --scan SBOM argument. Again, that means send the SBOM to Inspector for a vulnerability scan. And I'll go ahead and specify the AWS region as US East 1. You would need to change that to your default region. And I'll write the result to disk as vulnscan.json. So be aware, if you are not invoking --scan SBOM, the -o argument will just write your SBOM to disk. If you're specifying --scan SBOM, then the -o will write the vulnerability scan to disk, and the SBOM itself is embedded into the vulnscan. So I'll go ahead and fire this. And let's take a look at the resulting vulnerability scan. Now, normally when I open these up, the first thing I do is I do a find operation or a control F for the keyword critical. And this will bring you to an aggregate summary of the number of vulnerabilities found in this artifact. So this is Ubuntu 14.04. It's a discontinued operating system. Here we can see it's got 48 criticals, 227 highs, and so on. Now, it may be worth your time to peruse these vulnerability scans in detail. There is a lot of vulnerability intelligence found in this document. You'll get the various vulnerabilities, references to the vulnerabilities themselves, the criticality, and much of this information can be very helpful when prioritizing or determining which vulnerabilities to remediate. Okay, so that's it for the demonstrations. Now, during this video, we showed you how to create SBOMs and scan your SBOMs for vulnerabilities using the Amazon Inspector SBOM generator, also known as SBOM Gen. So now you have a new set of tools to enhance your vulnerability management practices, both within and outside of AWS. So we hope you found this demonstration useful and helpful for your security needs. If you have any subsequent questions, feedback, or need assistance, don't hesitate to reach out to us at inspectoropensource@amazon.com.